I'm Stephen Foskett, organizer of Tech Field Day, and we are here in Austin, Texas with a group of international delegates who've come in to learn and discuss and ask questions and interact during this technical presentation. You're about to hear from Uila, which is a new company to this audience, and I know that there will be a lot of discussion. If you'd like to learn more about Tech Field Day, go to techfieldday.com. You can also go to youtube.com/techfieldday to see more videos like this.
I'm Roger Yao. I'm from Uila. Right now, I'm Uila's VP Engineering. Today, I'm going to do the first demo. The first demo's topic is application visibility and root cause fast. Please allow me to switch to browser. So as you can see, I already logged in to our portal. No matter you are using on-prem or SaaS model, this is the first page you hit after you log in your portal. So basically, this is the single pane of glass view where you can monitor your data center's health from multiple aspects. If you take a look at the timeline at the top, right, vertically, it could be divided into 5 rows: application performance, CPU health, memory health, storage health, network health. Right? As you may notice, there's time slider on the timeline which you can move around to focus on the more suspicious or more interesting time period. Then the graphics, the color wheels, the widgets got refreshed, right? Reflecting the data center health in each category. As you can see, 5 of them are color wheel widget, where you see the big circle. Right now, it's pretty colorful because, as you can see on the top, it's not very healthy, your data center. Especially for the application performance, it's pretty red. Something is going wrong, right? Before I drill down to do the root cause analysis for more detailed information, I do want to give you a little bit interpretation on how we structure this color wheel. So maybe I expand this widget for a better view. So at the core of this color wheel is your data center, right? Going outward, it's a cluster layer, host layer, and VM layer. On each layer, you can see there's multiple sectors or slices, and each slice represents one entity on that layer. And for each entity, Uila keep track of a set of performance metrics, and we build up the baseline, and we know whenever it's getting worse or getting better. When it's getting worse, we use color to draw your attention. That's why you see the orange and red and green and yellow, right? And if I move my mouse over to this big guy, all kinds of detailed information you can see on this tooltip. It's telling you, the application statistic, like application response time, how many traffic, how many transactions, and it lists out the protocol type we detected on this VM, right? For each of them, whether they are, performing well or not. Next to this color wheel, we got the table, right? VM table, host table, cluster table, and we list out all the, statistics we are tracking. And you can sort by any column, right? Sort by health score, and the worst one or best one pop up on the top. The key takeaway from this dashboard is because it's so easy for you to identify the hotspots, right? So that's why a lot of users, they really trust the dashboard. It becomes their daily work. They log in our dashboard, check it to see whether there's hotspot. If there's no hotspots, they feel comfortable and confident about their environments. And there's one customer from from the China's biggest sportswear retailer. The CIO really loved this page. Every morning, like I said, he just log in, quickly take a glance, no red, he's happy. We do provide you another way to take a look at your application performance. It's going to be the next screen I want to highlight. This is the topology map we automatically draw for your multi-tier application. The first thing I want to highlight, this topology map is automatically drawn and laid out in such nice format. The key benefit of this is very quickly, the dynamics of your multi-tier application, the whole chain of the application, who's talking to who, right? How many VM got involved, that type of information. More importantly, customer always being surprised by this kind of topology because we always discover something they haven't known before. For example, a suspicious VM show up in this topology, a suspicious link pop up in this topology. They quickly know there's something he didn't know before, right? And in this case, Take a look at this topology. At the front here is application load balancer, and behind it there's two WebLogic server, and behind the two WebLogic server there's a bunch of database server. And the other beauty of this topology is very quickly you can spot the bottleneck of your multi-tier application because the bottleneck light up as orange or red bar, right? If you move your mouse over to it, the tooltip telling you, yes, it's not performing well because the application response time is so long. My SQL service, which is critical, is not performing well. That's why it light up as red. And before I click this MySQL service to do the root cause analysis, I do want to highlight another point on this topology, which is this external devices who show up as a gateway and it's serving DNS. So it's telling us all of the VMs are pointing out of the data center to these external devices. So basically, that's your DNS transaction, right? The reason I mentioned this is a couple days ago, the customer bring up this topology map. He quickly noticed the DNS service is very slow in his environment. The application time take 1 to 2 seconds. He was surprised by that result, and he take immediate action to remediate the problem. Now let's circle back to this bottleneck, which is Oracle 11g N1. And I'm going to click my SQL service to do root cause analysis, basically to find out why my application response time is so slow. Okay, I hit the button. It's going to lead you to this root cause view. This is the place where you can correlate your application degradation with your infrastructure issues. As you can see on the top, there's two trending lines. The first one on the top is application response time. The second one, which is the white bar chart below it, is transaction volumes. We automatically select this problematic time period where the ART is above the threshold. That's why you see the red bar. And if you move your mouse over to it, the tooltip telling you, yes, your application response time is way beyond the baseline. And what's next? The middle part, we use the small windows to tell you, don't worry about your CPU health. Very healthy, no correlation. There's a little bit correlation with memory health, but that's not your major concern. Take a look at your storage health. It's super bad. It's very red, right? 100% correlation is strong. And also, the DNS show up as a dependent service. Basically, it's upstream application, right, which is serving this MySQL service on this database server. Before I click the storage health to show you what's going on in my storage, there's another section at the bottom, which is quite important. We call it worst transaction. Basically, we pick out the worst 3 transactions per minute, and we give you the detailed information, including application response time, who's the client, who's the server, what kind of service, and the detailed metadata in the request and reply. Imagine sometimes you have no infrastructure at all, right? Which means all these small windows are green. So in the infrastructure guy, but your application is still running slow. At this moment, the infrastructure guy can capture a screenshot, share this with his application colleague. Application colleagues say, no, okay, I cannot blame infrastructure. There must be some reason inside of my application. That's when this worst transaction metadata is critical to them. Okay, now let's circle back to the storage health. I'm going to click on it to take a look at the storage picture at this moment. Okay, 3 tiers. We list out the rewrite latency, rewrite IOPS at all 3 tiers. Host kernel layer, vdisk VM layer, and physical storage layer. The first thing that captured my eye is the read latency across all 3 layers. They are not performing well. It's quite slow because the background color, that's why the background color is orange and the bar is red. And I want to focus on the lowest level, which is the physical data store level. Because if your physical data store is slow, there's no way to achieve better result at the upper layer, right? Virtual layer, host kernel layer. And more interestingly, you can see strong correlation between the read latency trendings and the read IOPS trend. And you suspect it may be something related to IOPS congestion. And the natural next step is to figure out who are using my physical storage at this moment. You just click a bar on the read IOPS. The tooltip telling you, OK, this data store is being used by this host. Host 4, which happened to be the host we are troubleshooting on. Right? That leads you to the next question. Who are using storage IOPS on this host? Basically to find out who are those noisy neighbors, right? If it's a storage congestion problem. So the list telling you, yes, there's the several VM who are using the IOPS resources at this moment. Then who's the culprit? You know who's the culprit, but who's the victim? Click a bar at the read latency on the host level. You know my VM, Oracle 11GN1, even though it's not using much, it's suffering the long latency. So right now, at this point, you got the full understanding, the full picture about the storage congestion problem, caused by the noisy neighbors, and my critical SQL service is getting impacted by this situation. Any questions at this point?
Absolutely. So what I saw was from looking at one single interaction between one stage of an application at the beginning, and please correct me if what I'm echoing back is not accurate, that found an issue, a performance issue, basically out of defined norms for a certain application stack. A dashboard showed in big red things that the circles were wonky. We're able to drill down into that and look at back over time what was the kind of the escalation of events that happened. And then the final screen I saw was looking at a multi-tiered application stack and being able to do the root cause analysis of what really caused this to be wonky. Almost like waves in a bathtub, right? You kind of splashing across and you kind of build it. What caused that wave to build?
Yep.
Yes, I love playing in the bath, still. Was that dynamically generated or statically generated, the relationship between those application stacks? Was that inferred through your application, or was that knowledge put in through a user?
Actually, everything is dynamically discovered by us, right? User doesn't have to do anything. They don't have to config. They don't have to input anything. Everything is automatically detected and stitched together like this way.
One thing that actually would be interesting to show is this is the time. If you notice at the top, there's a time bar, right? This dynamics like this for that time. If you move that time bar to some other time period, the application topology actually changes. Roger, if you move it to somewhere else, it changes dramatically, depends on the time. So it's very dynamic. Sometimes for troubleshooting that's during that 1 minute, we narrow the time to 1 minute to say during that minute, what transaction actually go through the application tiers. Then you find the issue more precisely.
Is the information that's generated from narrowing that time window dynamically computed, or are you running these back through some sort of algorithm to be able to take a closer look and a more granular look at the data flows that are being inspected?
It's dynamically
generated?
Dynamic generated.
Are you taking the user input of where they're clicking, the time ranges that they're looking for to provide input to the models on the back end?
Yes.
Is that training data used over time so that the next time an issue like that happens, that there is at least a reference or or let me state this question, please. Are you taking this data that you're using for real-time training to provide insights and alerting as it happens when that user is not interacting with that application?
Meaning?
Let me restate the question then. So what I heard you say is the user interacting with this application of drilling down between elements that are out of norm, right? And zooming into timeframes are providing variables that are being passed back into your platform, either on-premise or not. That is Hadoop-based, I think you described. And then it's taking another run of that algorithm and then presenting that information back. Is that information captured either per user or as a larger user set to provide kind of a preset of insights to make it easier to determine the root cause the next time this happens?
It is, well, the graph is per user. So the graph is automatically generated. User can kind of move it to different location and then save it and then bookmark it.
Okay.
But the alert that we generate is not based on the graph. The alert we generated is per virtual machine or per application server that has less to do with how the topology is being put together. So for example, you have this topology. You can see there are 2 red dots in there. So we probably generated alerts for both of those too.
I think I may have figured out how to more directly ask my question. Are you retraining the model each time? Or over a certain period? So what I saw, and it's actually reminded me, I won't go into it on tape, but I've had the opportunity to observe modelers working to generate algorithms for like fraud analysis, risk analysis, stuff like that. That process of introspection and interaction, from what I heard you say, is coming, you're in real time providing information back to the model and using that to provide more insight. The derived model that came out of that action, is that retained so that an organization that has a senior level engineer that's going through troubleshooting is able to capture that process that's in their head with the information that you were consolidating so that, say, a junior level engineer in that organization will have access to those insights the next time this happened?
That's a great idea.
Yeah, it's a great idea. Right now, we don't have that feature yet. But actually, like Jiaqi mentioned, at least right at this stage, we can bookmark this finding, right, for the junior engineer to look into, right? And they do require some training to get familiar with the workflow. Yeah. What you are talking about is automatically, going through the pattern, the flow, right, to identify the problems.
In no way knocking that it's not there. This is very, very impressive.
We did have people ask that, well, you're able to automatically come to root cause, right? In this case, we do generate alert and we say root cause is there. We do record that. But over a period of, say, 3 months, for example, can we consolidate all these findings, right, in terms of alerts, deviation from application performance? 95% of the time is because of one storage device is causing that issue. So that experience accumulated over 3 months, being able to conclude that for a junior engineer, and then so he can actually do optimization, is something that we learned today. It's great. It's a great idea, and I think toward that direction, people do ask, but we haven't had that. It's a great idea, though.
Thank you.
So while we're on the subject of feature requests.
Question, not a request, by the way. I didn't request it.
Okay. Well, let me ask if you have this feature. Do you have anything for those who might be red-green colorblind? Looking at your data on there, there was a lot of green, 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 red, green, green, green.
Or even here.
And, even in here, someone who might not be, who is sensitive to that probably couldn't see that there's a problem. So is there a switch in there or anything that would change up the colors to more contrast or?
Yeah, we did encounter this kind of question. And right now, we don't have that feature for the colorblind people, but potentially, you can do something in the preference where you can change the skin, change the color to fit their needs. But it's something in our, in our roadmap in the quarter of this year. So don't worry, we're gonna make it.
To provide context for that, that's actually a fairly common request that we get from Tech Field Day delegates because I think statistically, colorblind people are a little overrepresented in the IT sysadmin crowd. So that would be a good addition.
Absolutely, absolutely. And then for some regulation, if you want to sell it into government space, that's a very strong requirement. So the only action, so far, I definitely admit we are not, well down there. We have to provide more. But one conscious decision that we made is our screen is very colorful and very graphic. One thing that we did do towards that direction is everything that you see, there are always numeric representation. For example, for this chart, it's graphical, but you can always click on, for example, table. Roger, if you click on the table tab, there's always numbers that showed up to represent. Obviously, it doesn't convey as much information, but at least we want to get the raw data in there. And that's kind of one step that we took towards that direction. But like tooltip popping up, everything that you see, you move your mouse to it, there's always tooltip popping up with that number for that particular node. That is also another conscious decision that we made for this direction, but not enough, definitely not enough.
I'd counter. I think this is really neat. I don't like or not that. Actually, I'll say I don't like hearing you say this is not enough. I think this is really good stuff. I think if I was in your shoes, I'd feel really, really proud about showing this off.
Thank you.
Thank you.
Welcome.
If there's no question, I'm going to switch to my deck because I do have a screenshot coming from our customer. I want to share it with you. A little bit case study. So actually, these two pictures coming from a hospital, right? After years of operation, people left, people joining, they kind of lose track of their email system, right? That's why the junior engineer joined this hospital, and he really wants to know how my how my email service looks like, topology-wise, right? And he bring up this application topology view, and he quickly realized there's so many database server as this layer, right? Look at this column. So many database server behind this email exchange server. He was surprised by the fact. And more important than that, the hospital, they have suffered the email slowing down every morning. They couldn't figure out what's going on, right? That's why they've used the time slider, focus on the problematic time period. They capture another screenshot where they quickly identify there's a bunch of bottleneck in this topology, and they are happy. Click one dot, drill down further, it turned out to be a CPU congestion issue. Any questions?
I was talking to a gentleman from Platform 9 yesterday about this application topology. And because this is automatically generated, a lot of time when we generate this chart for the customer, many customers are very surprised. Sometimes they challenge the validity of it because it always looks a lot bigger than they anticipated. They go, no, I don't use that service until we really provide that. So the Platform 9 gentleman was making a comment, which we think is very interesting, is A, you surprise them. B, in real case, this is very useful in a scenario where a lot of the time you do data center migration or you migrate an application. So you need to pick up an application from point A to another data center or even to the cloud or to some. So this will really tell you when you move it, what do you need to drag along with it for that migration purposes. So application topology a lot of times serve a lot of services.
Well, and that was one of my observations I was going to point out too, is there's a market for application dependency mapping.
Yes.
Especially with especially with SDN and some of the different vendors out there, and not to say anything bad about applications people because it's very complex, but oftentimes they, to your point, don't know all of their stuff. So you're trying to optimize it across an SDN platform or something, and they don't know what half the dependencies are, and it's very difficult to find. This would be maybe slightly off of your target market, but it would be a good use case.
Yeah.
And I bet it's cheaper than buying titration.
Well, yeah. I didn't say that, though.
With the application mapping, I'm on the online demo, and I see there's some grouping. Is that a manual grouping of saying, like, in your demo, you have a bank company that has two servers in a little light shaded ring around them?
Right.
Is that a manual process, I would assume, setting up those groupings?
In that case, that's a different view. Maybe, Roger, you can quickly go to that. That's a different view of your entire data center. Mm-hmm. So the way that we group is we group all these VM by the VLAN or port group that they sit in. And then in this case, you can see many islands or the grouping that's grouped together. You can see all these guys cross-talk to each other. This is a messy chart, but this is reality in your data center. Each group is a port group. It's a VLAN. Right? And they do talk to each other. There's one, because VLAN is defined by port group in the VMware, so we can put it out automatically and group it for you.
Yeah. So if we assign like a group like that, like we were just saying, can I set permissions on that specific group where if user A logs in, they can only see anything that happened to the servers in their application group, if I chose to say, these three, this web server, this application server, and this database server was application A, these admins can only see the stuff relevant to that.
Yeah, so we do have multi-user role type of support. So that is defined by the virtual controller as a domain, not to per port group yet, but I think we'll probably need to get to that level for multi-tenant, because for service provider, typically each tenant is probably a port group by itself. So we will get to that level.
Thank you.
I think being able to see performance on an application base, which I think is what you're trying to say, is that you have a web server, you have an application server, you have a database server, all these things are grouped together. I want to see in that application stack, based on this logical grouping that I've created, where is the bottleneck that exists? So is it the app server, and the app server is having an issue because the host that the app server is sitting on is having CPU contention issues? To take that one step further, to also be able to bring that information from vCenter based on tags, like these VMs are tagged with this because it's part of this application in the production environment, and now I can dynamically create those application mappings within your tool and be able to see that without having to create my own and have that manual process.
That is perfect. I love your comment. I love your comment. So the way that we're building for that, we're still hoping people to use it, right? Is by leveraging the vApp concept inside VMware. So if you define vApp, then we have a tab there that we group by vApp. Then it will do exactly what you asked, right? But I think right now we're still trying to get people to do that. That's really a powerful way to look at your entire data center and group them based on the way you want to see them. Right. By default, we group by VLAN, by host,
Port group,
and by port group. Yeah.
So what about in the instance where there's an external service which this application is interacting with? An example would be a financial transaction stream where you have to bounce between multiple different data centers and shops providing information to it, or a simple transaction of an external payment or authentication service that is outside of the view of the scope of the data center but is interacting with the application stack inside. How would you provide insights that would help to identify where that issue is, and what would be the challenges and limitations that you might foresee?
Yeah, if there's some VM sitting outside of the current data center, right, and talking to the VM inside the current data center, the VM going to be show up as external devices.
May I clarify? Yeah. What if I'm interacting with an external SaaS platform, such as Salesforce.com? So I'm using Salesforce to authenticate in my end users, but I have a Salesforce application which is connecting with an internal data store to provide customer insight. In that example where I have no visibility to Salesforce's infrastructure, I can provide an application. I can provide an SSL key to be able to gain insight into the secure transaction, and I have in this case very deep insight into my internal data center. In what way could I use this tool to provide insights to see whether the problem is in Salesforce? Say my salespeople can't log in, or my salespeople can't generate their reports to figure out who they should talk to next. In what way could this application be used to help remedy that issue?
That we can
use. So if you switch back to the dependency map, I mean, the example that Roger gave earlier on about DNS, right? We will see DNS through the eye of a gateway. Okay. So we do detect a gateway because all the external services, it does go to, from whichever node that we monitor on, we see the traffic go to a gateway, and then we all go to Salesforce, right? So we don't draw Salesforce or Google, but we do draw that gateway. We choose to stop at the point where it's immediately adjacent to your data center. So through that gateway, if you point to that gateway, you see upper right corner. In this case, you see DNS, because my DNS service is provided by the outside DNS server. If it's their Salesforce, I'm very confident if there's a Salesforce transaction going on, we will recognize Salesforce. And we will say Salesforce underneath DNS. And if Salesforce response turns out to be slower than it usually is, it'll be a red Salesforce item in there. And you can click on it, and we will show you the transaction. We will show you the number of transaction and the transaction record. but I won't be able to drill down to say it's a CPU issue, memory, storage issue, because it's Salesforce.
So feedback?
Yeah.
This is positive, by the way. If this had been around 12 years ago, I was a startup doing high-dimensional mathematical analysis of financial transactions to identify fraud risk. That was in the transaction stream of most major providers. When our transactions busted 240 milliseconds, I think, we had 3 transactions before we got busted out of the stream. Transaction, which meant we didn't make money off the financial transactions. An hour can cost millions.
Right.
This would have, and I ran operations, and I had teams under me that I would have killed for them to have this dashboard configured in a way where if one of our clusters, either in America or in Europe or others, had and its interactions with LexisNet, external data sources, external customers, internal data sets, to be able to have the more junior people in the organization to provide insight and troubleshooting. One, it would have provided years of sleep back to me, which is the most important thing. I had a 1-year-old at the time. It would have actually given me more time with my son. And that's more important than any of that, but it would have saved the company millions.
Yeah, to your point, yeah, I think that's a use model where we can make this graph real time. So every minute it would update. So it could be a dashboard. We actually do have customers who use this type of thing as dashboard. So it moves as time.
Yeah.
And then the topology graph would actually change every minute.
And so you mentioned that everything's provided in tabular data and stuff like that. Say if I wanted to integrate into like Nagios or any alerting stack out there where it's a direct application probe noticed that transaction got munched. Do you have the ability do you expose like a publisher subscriber interface in and out of your system that would allow a monitoring console to be able to do a one-click drill down and pass the information what it's looking at and bring down to the couple clicks down that you became? Is that within the features of your product? Or the ability to do so within integration?
Yeah, yet another great idea. We don't have that yet. Right now, the only thing that we do is we do alerts, we send email notification, SNMP, all that sort of standard thing, but not a complete flow.
It sounds like you have professional services, right?
Yeah, we do have. So we can help you to integrate it.
Okay, so it is that. Yeah.
Yeah.
Yes. Okay. Cool.
Yeah.
That's really neat.
Yeah.
That specific use case, and it was 12 years ago, and I think it was bought by LifeLock, so you can't sell to them anymore. Maybe just go sell it to LifeLock.
Yeah.
But that would have improved my life, would have helped me spend more time with my son, and would have saved the company a lot of money.
Sorry, we're 12 years too late.
Well, I'm glad you're here now.
Excellent.